Good. The next time I'll come to your school to teach you there, okay?
Yes.
You like that?
Yes.
Okay. We'll see. We shall see.
Teacher, you will come.
Yes, I will.
I will be waiting for you.
I will be there. On a serious note, make sure you pass after Corona.
Okay.
Make sure we disapprove Corona.
Okay.
Tell Corona that you cannot puny us. We are children of God, isn't it?
Yes.
Good. Adasa. Adasa. Yes, your name must be mentioned in every recording so that everyone who watches this clip must hear the name Adasa. They will say Adasa. Michelle Mushiri, how are you?
I'm fine.
I'm waiting for a few others to come in so that we can begin together because I don't want to repeat. So you just give us a few seconds or a few minutes, 1 or 2 minutes for the others to also come in so that we are all here together. In the meantime, I can get myself some water. Good, let us begin now. If your camera is operational, please turn it on. And all stop hiding behind that image there. Good. Okay, let us now begin. And our topic of discussion now is going to be excretory system. We have discussed the reproduction. Now let us discuss excretion. Excretion. The first question we ought to ask ourselves is, what is excretion? What is excretion? You can tell me what excretion is.
Excretion is the removal of waste from our body.
Good. Excretion is the removal of harmful substances or harmful products from the body. Remember that body processes like digestion, respiration, breathing produce waste products. Body processes like digestion, respiration, circulation, and breathing produce waste products like they produce waste products, e.g., they produce water, excess water, they produce excess nitrogenous wastes, they produce excess carbohydrates, they produce excess water, they produce excess nitrogenous wastes, they produce excess carbohydrates, and they produce carbon dioxide. Therefore, excretion is the process of removal of these wastes from the human body so that the body remains pure. So that the body remains pure or clean. And therefore, We now want to look at the excretory organs. What you are required to know here is number one, the excretory organ. One, you need to know the excretory organ. Two, know its excretory products, excretory organs, and the excretory product. So let us start with a small area which is excretory organs. The excretory organs that we have in the body include one, the skin, which is basically the largest organ. The skin, largest organ in the body. We have the skin, and the waste product produced by the skin is sweat. The waste product produced by the skin is sweat. Then number two, we have the lungs. We have the lungs. And the waste product we get from the lungs is carbon dioxide. And of course, we also get sometimes excess what? Excess water. Excess water. We also have excess water. Then we have the kidney. The kidney. What is the excretory product of the kidney? You can give me the excretory product of the kidney? Yes, Michelle?
Excess salts, water,
Yes.
and urea. Excess salts,
Yes,
water,
we have
and
something we call urine, isn't it? Urine. What you are now giving me is the composition of urine, but we produce urine, isn't it?
yes.
Yes, it is urine. So what you are giving me now is the composition of urine. So that is urine. There, because urine is made up of, now you are giving me, we have excess salts, correct? It's also made up of excess water. What else?
Urea.
Urea. So what you are giving me now is composition of urine. So we have the kidney, which produces urine as an excretory or as a waste product. So let us begin with the first one, which is the skin. We have done a quick summary, so let us begin with the first one, which is the skin. Let us begin with the skin. Now the skin is the largest organ of the body. The skin is the largest organ of the body. The skin is the largest organ of the body. It is the largest organ of the body. This thing we call the skin. Number two, the skin consists of two layers. The two layers, which are the outer layer and the inner layer. Now we have the dermis and the epidermis. Which one is the inner layer? The dermis is the inner layer. The epidermis is the outer layer. The dermis is the inner layer and the epidermis is the outer layer. Epidermis. Yes, Beverly, are you okay? Beverly, are you okay? So the epidermis is the what?
Outer layer.
Outer layer. Now, once we know the layers, then we know what is found on which layer. What is found on which layer. So that's what we're going to look at now. Find on each of the layers that we have. What we find on each of the layers that we have. For example, we have an opening called a spore. Where do we find the spores?
In the epidermis.
The spores are found on the outer layer. So the spores are found on the epidermis. They are found on the epidermis. They are also called sweat pores. They are called sweat. We also have they are called sweat pores. Number two, we have those things that we call sweat glands. Where are they found? The sweat glands. Sweat glands are found in the dermis, correct? The sweat glands are found in the dermis. Sweat glands are found in the dermis. Sweat glands are found in the dermis. Then Remember, the sweat glands are coiled. You see those coiled tubes, eh? Coiled tubes. You see those coiled tubes in the diagram of the skin. Then you know that those are called sweat glands. And they help, they also contain blood vessels which help them to transport what? Transport waste from the other parts of the body. Then the sweat cools our bodies. The sweat cools our body. Sweat cools our body. Remember, the main function of the skin is to, the skin cools the body through sweating. As the sweat evaporates, it cools our body. As the sweat evaporates, it cools our body. The other thing that we are going to look at is the hair. Where do we find the hairs? The hairs are found in the dermis. Hairs are found in the dermis. Hairs are found. So let us briefly say what do we find in the dermis. So let us just write dermis or outer layer. On the dermis or outer layer, we find the following things. Number one, we have sweat pores. Sweat pores. Number two, we have hairs. We have the sweat pore and the hairs. They are found on the epi. Where do you sweat pore and the hairs? Someone is talking to me. Briefly, you are mute and you are talking. Yes, where do you find sweat pore and hair?
Epidermis.
On the epidermis, correct? On the epidermis? Are we writing? Someone is asking, are we writing? Now that will depend on whether you are learning or not. Usually you have to take notes, don't you? You will take notes. Let us continue. Then we have gland, oil gland. We have sweat gland. We have sweat duct. We have hair root. And we have the fatty tissues. Eh? We have the fatty tissues. Where do we find the first? Where do we find the oil gland, sweat duct, hair root, and fatty tissues? Where do we find them? In the? In the dermis, eh?
Yes.
The dermis, correct. So once we know where they are found, then we are okay. So we need to know where those two are found. Now, once we are through with that, now we go to the next thing. We go to the next thing, and the next thing we look at is the lungs. Let us now go to the lungs. The lungs. Now, the lungs. The lungs produce the waste products that are carbon dioxide and excess water. So the excretory product of lungs is carbon dioxide and excess water. The excess water is breathed out in terms of water vapor. The excess water comes out in terms of water vapor. And this happens when blood-rich in carbon dioxide reaches the alveoli. The carbon dioxide moves the blood to the air sacs, and then it is breathed out as a waste. So we don't need to know much here. We only need to know that these lungs remove carbon dioxide and they remove excess water, which is breathed out in terms of water vapor. The next thing we look at is the kidney. Now the kidney, we need to know the structure of the kidney, the physical structure of the kidney. Remember, these are two bean-like structures. The kidneys are two bean-like structures. They are two bean-like structures. They are two bean-like structures that have two bean-like structures that are found there. They are two bean-like structures. Now, these two bean-like structures, you must know their physical structure and you must know the parts. You must also know the parts. So, I hope you have drawn the kidney. We know the kidney, and then we name the parts of the kidney very fast. Let us name the parts of the kidney. The parts of the kidney, we have the ureter, then we have the kidney, then we have the urethra, then we have the bladder. Which one comes there? We have the ureter. Ureter, which carries blood. Ureter carries. Someone is calling me, yes? Who is calling me? So you start with the left kidney. Left kidney. We have the left kidney and we have the right kidney.
Right kidney.
Under the left kidney and the right kidney, those two tubes that leave the kidneys are called they are called ureter. So the ureter connects the kidney to the bladder. So you write, ureter connects the kidney to the bladder. Ureter connects the kidney to the urinary bladder. Ureter connects the kidney to the urinary bladder. Then, of course, under the ureter, we have the bladder, which stores urine temporarily. We have the bladder which stores urine temporarily before, of course, it is removed. Then we have urethra. Urethra, which is the passage of urine out of the body. Passage of urine out of the body. Passage of urine out of the body. I hope you have drawn your kidneys. Let me see your kidneys. Yaoko, let me see your kidney. Yaoko, let me see you. That's okay, Yaoko. That's okay. I've seen it. Felicity Nyambu, let me see yours. Felicity. Felicity is not showing me hers. I don't know why. Yes, let me see. Yes, Nacho, I can see yours. That's okay. Nacho, that's okay. Can see yours. That's okay. Then Hadassah, Hadassah, that's okay. That's good. Good, Hadassah. Very good. Natalie, I've seen yours. That's okay. Natalie Mukami, I've seen yours. Good. So I hope you have labeled the parts of the kidney there well. So from there now, we look at the next thing, which is now, because the urinary product of the kidney we've said is the urine. The kidneys filter blood and remove water, excess salt, and urea. The three combine to form something we call urine. So composition of urine, we have water, excess salt, and urea. And of course, the urine passes through ureter to the urinary bladder, where it is stored. When the bladder is full, the urine is removed through the urethra. Mumtaz, your hand is up. How may I help you?
How are you?
Mumtaz?
Malim,
Yes?
I wanted to ask you a question.
Ask.
And girls have urethra.
Urethra?
No.
Urethra?
Yes.
Yes. Up there, between the kidney and the bladder, we have ureter, right?
Yeah.
Then after the bladder, below the bladder, we have urethra. Okay? So the passage of urine out of the body is urethra. Then the passage of urine from the kidney to the bladder is urethra. Is that okay? Are you answered?
Yes.
Good. Let us continue. Let us now continue. Felicity. Felicity Nyambura. Felicity Nyambura. Felicity. Question 1 is yours. Answer question 1. The blood vessel, now let me not go there, we did not discuss. Which of the following is not an excretory organ? Which of the following is not an excretory organ? Skin, lung, kidney, rectum.
Rectum.
Yes?
Rectum.
Rectum, correct. The rectum is not a, by the way, that reminds me, please note, NB, the anus is not an excretory organ. The anus is not an excretory organ. The anus is not an excretory organ. Of course, anus and rectum, they are not excretory organs. The anus is not an excretory organ. Just like the nose is also not an excretory organ. The organ is the lungs. The nose, the anus, those are not excretory organs. So the anus is not an excretory organ, same as the rectum. Next question. Next question. Which of the following is not, we read that question. The following are processes that takes place during birth in human beings. Dilation of the cervix, contraction of the uterus, bursting of the amniotic sac, pushing out of the baby, cutting of the umbilical cord. Arrange them in order. Give me the first one. First one. Contraction of the uterine wall, correct. Number 2. Number 2.
Widening of the cervix.
Opening or enlargement of the cervix, or dilation of the cervix. Number 3.
Bursting of the amniotic bag.
Bursting of amniotic bag, correct. Number 4. Pushing out of the baby. 5. Coming out of the baby. 6. The umbilical cord is tied and cut. 7. Expulsion of the afterbirth. Expulsion of the afterbirth. That brings us to the end of human body class 8. That brings us to the end of human body class 8. Any question up to that point? Any question up to that point? Any question?
No.
No question? If there's no question, do I move to the next topic or I revise energy as was requested by someone? What should we do?
Next topic.
Move to the next topic.
Okay.
We move to the next topic or we revise energy class 8?
Revise energy, madam.
Let us revise energy class 8 briefly for the sake of those who are not there, so that when we meet next, we move to the next topic. Is that okay? Those who are here, this should be easy for you because we have done this, so you'll be answering my questions. That's our
Yes.
energy class 8. We were discussing energy class 8. Let us go there very fast. Energy class 8. Energy class 8. Energy class 8. Look at the topic, energy. What is energy? Michelle Wanjiru? Wanjiru, what is energy?
The ability to do work. Energy is the ability of work.
Energy is the ability to do work.
Work.
Energy is the ability to do work. And so, once we say that energy is the ability to do work, it is therefore right also to say that work is not said to be done, rather energy is not consumed when work is not done, isn't it? So energy is the ability to do work. In class, from class 4, 5, 6, 7, 8, you discussed those forms of energy. You discussed heat, you discussed, in fact, in class 5, you dwelt much on heat. In class 6, you discussed light, okay?
Yes.
You discussed electricity. That's how, and
Yes.
I guess the last thing you look at is, the last thing you look at in class 7 should be mediums of transfer energy. Mediums of transfer of energy. And we talked about mediums of transfer of energy. I guess we talked about that. The mediums of transfer of energy. And we said that that can be summarized as helinome, and soeleme. That is the first thing I'm starting with. The mediums of transfer of energy. Mediums of energy transfer. We talked about helinome and soeleme. Helinome, where helinome means he for heat, li for light, then nome means no, medium. Me means medium. Medium. In other words, heat and light energy require no medium to be transferred from one point to another. So they require no medium. So you say helinome. Then we also said soeleme. Soeleme. Soeleme, where we have so on top. Then we have ele together under so. Then we have me, where so is sound energy and electrical energy. Then we have me, which is medium. In other words, sound and electrical energy require a medium to be transferred from one point to another. So I'm talking about helinome and soeleme. Now, helinome, heat and light energy, no medium. I hope that is clear. Soeleme, we have sound and electrical energy, require a medium. Require a medium. Mercy Jaoko, are you okay? Good. Now, from there, we now went to class 8 proper. When in class 8 proper, you're dealing with something we call energy transformations. We say transform. To transform is to change. To transform is to change forms. So in class 8, you deal with energy transformations. That is the changing of energy from one form to another while it is in use. So for energy to be used, it changes form from one form to another, from one form to another. So we looked at several energy transformations that you are supposed to use or to know in class 4 for the sake of your, rather in class 8, for the sake of your KCPE, for the sake of your KCPE. And the transformations that we are supposed to know can be summarized as follows. The transformations we are supposed to know can be summarized as follows. Number one. Note that whenever you see food mentioned, or you see a cell mentioned, or you see fuel mentioned. When I say a cell, I mean a battery, wet cell or dry cell. When I say fuel, I mean kerosene, I mean firewood, I mean coal, I mean things like what? Those burning fuels. When you see food, of course, you know food. So whenever you see food, you see a cell, or you see fuel mentioned in any question or in any note, then you will know that here we are talking about chemical energy. Chemical energy. Yes? Someone said pardon? So I say that whenever you see food, whenever you see a cell, and whenever you see fuel, then you know that is chemical energy. We talked about the other forms of energy. You talked about electrical energy. You talked about them. You talked about heat energy. You talked about magnetic energy, right? We talked about kinetic energy, that is energy in motion. Energy that is produced or that is used up when things are moving. Moving objects have kinetic energy. So for example, if I have a torch, so let's write transformations, energy transformations. Our topic is energy transformations. Energy transformations. Transformations. Transformation 1 is the transformation or changes that take place, the changes of energy that take place when a torch that uses a cell, when a torch that uses a cell is switched on. Energy transformation that takes place when a torch that uses a cell is switched on. So it starts with the torch using a cell. Torch using a cell. Let me have ORPA. A torch using a cell. We have said that when you see a cell, we talk about which type of energy, ORPA. ORPA has refused to talk. Achien.
Yes.
Which type of energy are we talking about here? A torch is using a cell, so the energy will start from the cell, isn't it? The cell is the source of energy, right? So which type of energy do we find in a cell? I've just mentioned that.
Chemical.
We have chemical energy, correct? So in the cell, the first thing we are going to have is chemical energy. Chemical energy. Then after chemical, you draw an arrow. After chemical energy, an arrow pointing towards the left, an arrow. Now from the cell, that energy will travel through a wire or through a conductor, isn't it? Now, which energy travels through a wire or through a conductor?
Electrical.
Electrical. Therefore, in the wire, we are going to have electrical energy. You can see how the energy is changing. It has moved from chemical, now it has gone to electrical into the wire. Now, in the wire, it will now go to the bulb. And we say that in the parts of the bulb, there's something we call tungsten. Those two small wires, the tungsten wires. And when current is passed through those tungsten wires, they get heated. And when something is heated, we have which type of energy?
Heat.
Heat energy. So the next type of energy we are going to have is heat energy. Heat energy.
Light.
Then when heat is produced, that wire is going to glow to produce what? Light. It's going to produce what? Light.
Light.
The changes of energy that takes place when a torch that uses a cell is switched on is, we start with chemical, then we will move to electrical, then we will move to heat, and then finally we get light. So before the torch produces light, several changes take place. Are we clear up to that point?
Yes.
So we are clear. Good. Now this transformation can be represented by the following. You can say can. Yes, what did we say? Can. Brittany, can.
Kept Helen.
Brittany, can.
Can every man keep a secret?
Don't add I. If you add I, you are adding something that is not there. Can every man keep secrets? Can every man keep secrets? So can for chemical, can for chemical, every for electrical, man, sorry. Hey,
Carol escaped
that's a different thing. Wait, wait.
Carol escaped Helen.
This is Carol, sorry. This is Carol escaped Helen last, sorry. Delete the other one to represent something else. Carol escaped Helen lastly. Carol escaped Helen or Hillary lastly. So you say Carol for chemical, escaped for electrical, Helen for heat, and lastly for light. Light. Now, the other energy transformations we have are the energy transformation in radio. Transformation number 2, a radio that uses a cell. A radio that uses a cell. A radio that uses a cell. Radio that uses a cell. We are starting from cells. So what is the first energy?
Chemical.
The first one, girls.
chemical energy.
Chemical, correct. Then from chemical we go to
Electric.
in the wire. There must be a wire connecting the battery to the radio, isn't it? So we'll have electrical in the wire. Then, of course, behind the speaker of a radio, we usually see something called a what? A magnet, an electromagnet. So that electricity is going to produce a magnet, so that we have magnetic energy. Then from magnetic, a speaker to produce sound. We say sound is produced when objects vibrate. So the speaker will be moving up and down. So we are going to have kinetic, because vibration is movement, isn't it? For you to vibrate, you'll be moving. You'll be moving. So that is kinetic, to show movement. And then after kinetic energy, when objects vibrate, they produce what? Sound. When objects vibrate, they produce sound. Boys and girls, time has come to be short. We will go back and revise the whole energy for the sake of those who are not there, and for the sake of revision for those who are with me, that is St. Peter's, girls. We'll revise that at a later time. Otherwise, science, we are taking a break, short break, after which we're supposed to begin with which subject?
English.
CRE.
We're supposed to begin with CRE up to 130. CRE up to 130. Those who don't take CRE, then we will at 2 for what? For English. Yes. So at 2 for SST. At 2 for SST. Good. At 2 for SST. So those who don't take CRE, you need at 2 exactly SST. For now, unless you have a question, see you. Enjoy the break. The lesson begins.
How many minutes?
You have a 10-minute break. 10-minute break.